Welcome to the first lesson of our computer science structured programming course. Today, we are going to go through the concepts of the C programming language, understanding how it can be used in real-world events or like just general applications, and play around with some basic examples. Currently, at the moment, I have our little help desk called CodeRunner in front of me. This allows us to interact with the world or the world outside of Resonite to be able to do these examples. If I come over here and wherever the button is, there it is, click that, I can type in the terminal and I can say, let's say, for example, like, hello. We get hello world, but if I come over here and I type something like H, then we get an invalid command. This allows us to interact with everything and provides a baseline for this class. So if I do this, I'll do that. Let's get set up for C, shall we? I'm not dying. Go here. We'll do this, so everything is fine. So in this basic sort of 2-hour lesson, we're going to be learning about some simple things inside of C. Things such as data types, kinds of variables that we get access to, how we can store them, how we can print stuff to stand it out, which is what people most usually say, the terminal or console if you're a Windows user, and being able to sort of read from standard in if we ever get around to doing that later in the lesson. So the basics of what we're going to be doing today is we're going to write a simple hello world program describing core concepts such as importing libraries or files for these libraries, understand how things work, and then actually writing the thing that prints to stand it out. So I'm going to just add some comments, but I would highly recommend at the top of your file, in your text editor provided to you so kindly by the desks themselves, to write a comment. A comment starts with 2 double forward slashes, and I'd highly recommend you put your name so that when you do end up saving this, you can put like name, dates, whatever you want. Just don't put passwords or anything that could be like sensitive information, because why? So we're going to do this. Give me 1 second. What we're going to do is we're going to go down a couple lines. We're going to do a hashtag include. This is a preprocessor directive, which specifically states, I want, I'm going to make that generate as a line, that we want a specific file. These files can either be local or in the folder specified or relative to the main file, which would be like main.c or whatever you want to call it. Relative file paths are usually encased inside of double quotes, so like test/test.h. H being our header file, which contains things like function prototypes, which we'll also be learning out later. So if we do include, well, we get rid of these string objects, and then we do less than arrow, stdio.h, do more than arrow, we'll go next line, do another next line, we'll type int, int being a variable that we can have. You can have int, float, character, booleans. Yes, we can have strings, but it's really weird. So we'll do int main. If theoretically, if you are using a compiler such as GCC, you do not need the int part. You can just call main directly, but there's some caveats with that. So we'll do some curly brackets. I'll actually make sure that actually renders on the thing. We'll do an opening brace, do the next line, I'll just generate a couple of those. We'll do another enter, do some spaces just so we can do it for pretty printing. We'll do print, F, and then inner string, hello, space, world, exclamation mark, and then backslash n. Backslash n is essentially a new line character, which when this gets printed, the terminal will say, hey, we need a new line. So it'll kind of press enter on the keyboard for us, pretty much. So we'll close that off using our round brackets or braces. Then we'll hit with a semicolon at the end, do another line. We'll put the squiggly brackets that we had before on there. And so now we have a simple printf hello world statement. So if I come over here and I save the file, and then I do this, and then, yes, I see the issue that we're having. Great. Amazing. I guess we're not going to be using this today. But yes, that's a simple hello world. If I was able to run this, it would print hello world to the console. But let's get into a bit more complex things. Oh yeah, here we go. I don't know. It's running on Windows. That's the main issue. PowerShell doesn't like me. So we're going to get into the basics of doing strings or variables. Let's make an integer. Int I equals 55, or let's do 50. Get a whole number. Do a semicolon on that. We do a new line. We can then state just to add some padding for that one too. You don't have to follow around what I'm doing, but it's also kind of rendered as well. Take your own approach to how you want to do things, you know? So we'll come over here and we will get rid of the contents of the string, and then we're going to replace it. So we're going to do I equals, and then we're going to do %, F, loading point. That's an int, so it's going to get a bit mad. %, F would usually, so we'll just actually come up here and we'll change this to a float. Do float I equals 50, print F inner string I equals %, F. We'll do a comma, or whatever those little ticks they used to use as ASCII art for drawing sad faces, and then we'll do I. And so when we run this, what will happen is it will grab the variable I, it will take its content and it will replace %, F with it. I don't have Kelly with me, so I can't. And so from here, what we can do is, what else are we getting from here? Yes. So what we can do is we can clear out. You're not taking args. You don't need args in C. Yeah, no, you arguments in C aren't really. Yes, you can do int arg C character pointer arg V, and it's like an array, but you don't need to do that in C, at least with GCC and TCC. Some compilers support not even being able to do any of that at all. Some compilers enforce and some don't. Yeah, that is something that does happen. So what I'm going to do is we're going to get rid of everything besides our include statement. You do not need, just as a reminder, you do not need the comments at the top unless it's for oh, hey, I was the one who created this, sort of, you know? So we're going to create a function. Here's the little funny part. We're going to make a function prototype. We're going to do int calculate capital A area. We'll do new line so that renders. And then we're going to take, that's not new line. That is definitely not new line material. We want int length colon int width. And then we're going to close that off, and then we're going to do a semicolon on that. This is a function prototype. This essentially tells the compiler, hey, you've got some casual things that we're writing. So we have a function. It has been defined, but the contents of it haven't. So here's this is essentially, we could, if we wanted to, put this in our own header file and keep it there for it. That's usually what the best practices are for things like this. However, just for this current class, I'm not going to be doing any of the best practices up to this extent of doing header files, because I don't think there's any need to. Give me 1 second. I must quickly grab this. Here we go, and I have more examples. Didn't put too many examples in the book. Oh yes, another thing too. Oh yeah, we didn't even write this. Okay, so we'll continue on with this. We'll do int calculate area. Now we're actually going to have to do it again. We're going to have to, without doing the semicolon at the end, because we're actually going to specify the contents of this. Int calculate area. And then we're going to do int length. Oh, yeah, just copy the entire part up here. I'm way too lazy for this. Honestly, it might even just be recommended to, damn it. Okay, so we'll put this in here. We'll do shift enter. We get a new line. Fill this in. Do another new line. We're going to. I'll just. Oh. Why did you change things without testing? No, I did test things. I was adequately. I thought I had made this thing had worked in Windows previously and a long time ago. I just haven't updated the actual commands inside of the source code for the runners. So from here, what we're going to do, just space, calculate an area. Calculating an area. This example is for calculating an area of a rectangle. So what we're going to do is we're going to use return. Oh, here's another fun thing. Because we need to return a number. So return. What is it? Length plus length times width, or star. From here, we'll do a semicolon, and then we'll close that off with a bracket. So this function essentially takes in a length and a width, and returns the length times the width. I think too good with figuring out what variable operators are. Yeah, no, it is times. Okay. So we'll do this. And again, get on the line. Typing in VR is such a pain. We'll do int main. Oh no, I forgot to specify return for main. This won't take any arguments because we're going to we're going to put them in. You're fumbling so hard. Yeah, no. Having a lot of issues with this. It was fine. Oh, hello, Carson. So we're going to do int L equal. And that's 100. Whoa. And then when it's line, int W equals 100. 5. Do a semicolon on that one. We're going to do the next one. Int area equals. Oh, here's another thing too. Function definitions or variable definitions. Int area equals. Calculate area. and then we'll do L, comma, W, and do a semicolon on that one because that's technically also a no. I don't want that. And we'll do this. Just make this look good real quick. So, there's calculate area, and then we'll be printing it. Okay, so here's another fun thing. We'll get more format specifiers. This time is, yeah, no, it's still just one. Yeah. Print F, no. And F, the area is, and then we'll do semicolon, we'll do a colon, space, string end. We need to put a specifier in there. Percent. It's not a decimal though, it's a number. I'm not too sure why I wrote D in there. Percent saying D, and then we'll do that. Area right down there. And now, theoretically, if I've done everything correctly. Yes, the area would be 50. Output is 50. So we have essentially written a simple function that gone through actually a couple of things, doing function variable magic, taking in arguments for a function, doing function prototypes, defining not just main, returning values from those functions, defining some variables where the return, where its assignment is from a function. So that's also another return thing. We print that through a format specifier. And so, what else? Smaller functions aren't necessarily the greatest. If you have a bunch of tasks that you want to do, but you want to share them amongst the big code base, what you'll do is we have this sort of paradigm in programming called functional programming, where all of the little tasks, such as reading and writing to a file, but you have some extra stuff that you add to the start of it. Those are small functions that you put inside of like a common.c or common.h. Common.h for the variable. For the function. What did I say? I just said it like a few seconds ago. The function. Amazing function prototypes, and those will go in the header file. Your main actual functions will go inside of your C file, which contains your source code. And so if you have a lot of code that you need to kind of share around amongst code base, having the functional programming paradigm be a thing that you can do for small little, large-ish snippets around, while still having all of it be in place, makes it a lot more easier. Because if you're making, let's say, for example, a library, or you're building a piece of software, such as like the Code Runner server, and you want to have access to being able to just provide these small little things for people to do, you can use the functional programming paradigm when you take a bunch of stuff, you put it into smaller functions and spread it out. Yeah, sure, there's more lines, but that saves you from having to dig into things that are 2,500 lines long just to pull out a small little bit, because you can reuse a bunch of the code, which makes not just a code base more efficient, you as a programmer, because it would mainly just be a bunch of function calls at the end of the day, because you've pretty much laid out basis. It's like building standard libraries for programming languages, where you just have a bunch of the things encapsulate like a sort of abstraction. So, where is it? Here it is. We're going to do another little quick one, a couple more actually. Yeah, we have a pretty good amount of time to do a couple more from here. So what we're going to do is we're going to create a simple, we're going to essentially define main without that int. So it's going to be a bit weird, but it's going to be pretty good. So what we're going to do in this specific example, we're going to print a Fahrenheit/Celsius table. So essentially from 0 to 300, stepping 20, we will be printing out Fahrenheit first, Celsius last. Well, Fahrenheit first, Celsius second, or last. So we're going to do main, no input, return things. We'll do new line enter 4 more times. I'm going to define a couple of things. We're going to do what was a function for variables. So int, and here's the fun part about C specifically. I know most programming languages do this, but the only ones I've really played around with that actually have this is C. So if we do FAHR, comma, lower, I forgot that R, comma, what is it? Yeah, I think it is, comma, Celsius, CEL. I'm spelling it wrong, am I? CEL. Yes, I am. And we'll hit that with a semicolon so we can close it off. That's technically a one-liner for assigning a bunch of variables at the start of your program, because you're essentially forcing the type. Even if you wanted to change it, you couldn't, to be int or an integer, the 1, 2, 3, 4, 5, or in lower with lower equals 0. Upper is 300, and then our step would be to be 20. So step equals 20. And so what we do now is FAHR equals lower. So we're going to set Fahrenheit to be 0, so it's not null. Because in C, usually you'll hear a bunch of people complain about null pointer dereferencing and a bunch of stuff. But since we're not actually using pointers for this example, even if you want to run this on something like code blocks or an online, another thing too is if you want, there's a bunch of handful good services online, such as Replit. If you have if you're like very active on GitHub, you can also use the repository VS Code editing service, github.dev or vscode.dev in a container. Or if you have code blocks installed, or like a C++ or CIDE that supports C, then you can also use that too. So if we do, where is lower? So we're going to get into the in main. Main in one file, no new lines. I'm not going to do no new lines. You need int or void main, at least some return type. This example actually doesn't need return types. Main, if you're compiling specifically with GCC, doesn't need it, at least from the last time I checked. Because this Clang especially doesn't need it. Well, at least that's something, yeah. But you don't, with GCC and Clang, you do not need a return type, at least from what I know. So far and lowers, we're going to get into a simple into Lewis. Oh, it did autocorrect. Okay. Oh yeah. Just like how you have if, for, else, while sort of things inside of Resonite, we also have them in C. That's pretty much of how you're supposed to do like logic. What does Protoflux call them? Flow. They're essentially our flow sort of things. So we can do a simple thing while FAHR is less or equal to upper, because we want to make sure that, because we're going to be stepping in the increments specifically defined by step in the int. So step is 20. So we're going to be stepping 20, 40, 60, 80 consistently. You can obviously change this number to get different results or higher like granularity, but don't change is less or equal to greater or equals. Otherwise you will kill not just yourself inside of Resonite if you use Code Runner, but everybody else. And if you run it on PC, you'll have it no issue. But it's not recommended to change lower equals to like higher equals. So we'll do that. We'll do new line. Did it again. We're going to Celsius, CELS. Thank you, autocorrect. Save the day. Equals 5 times, and here's a little fun thing. We're going to do FAHR minus 32. So we're going to do a simple maths calculation that I'm not solving because I'm too stupid for that. And then we're going to divide it by 9. Obviously, there's a much easier way of calculating Fahrenheit to Celsius, but getting around to actually writing proper example than the one I'm using today. And then we're going to go new line, double space. That's triple space. Okay, that makes sense. The return type raises a warning. Yeah, no, it's a warning. It didn't specifically state. Okay, so yeah, you can provide return types. It's just if you end up using like no return types in your functions, or just main in general, yes, you will get a warning, but it will still compile as well, which is also a handy thing too. So we're going to print F, then we're going to do a string. Here's our fun part. We're going to have we're going to do this weird thing. So we're going to do %D. That's not 5D. %D \T, which is a tab in our terminal. All we have to do is, and this is going to get very tricky and complicated really fast, is what we can do, get rid of all of this and only keep Fahrenheit, which sounds stupid, I know. But if we put a semicolon there, we do a next line, and we'll get into the next cool things, the for loop. So for, if I wouldn't start dying, I could actually tell you. So for FAHR equals 0, because we already did the definition at the top. Otherwise, you'd be doing int var is 0, semicolon. FAHR is less or equal to 300, semicolon. And then we do FAHR equals itself plus 20 or 30 or whatever number you want. We'll do 20 for this. New line, do that. couple new lines during the entire thing. Space. What we're going to do is we're going to print F, and then this one's getting a bit weird. Percent sign 3D, so that essentially saves us gives us 3 decimal points. Actually, print as a decimal integer. Yeah, pretty much. Yeah. When here be printed at least 3. It's okay. Percent sign 3D space percent sign 6.2 F. 6.2 F is printing as a to the decimal point. So we have like 5.00 for example. So
Charlie,
and that
couldn't you just do like? Can you just do far plus equals?
Plus equals wouldn't work in this case. I think it's just syntax that causes the issue.
I thought plus equals works.
Plus equals none would also work. Yeah, you can always do plus equals. No, but Fahrenheit. Oh,
And also for the original thing, when you want floats.
so we are gonna does that call for a new line? Yes, that does call for a new line. So there's like one number after the floating point. That's not 6.11. It's not print enough to kill the 32-bit integer limit. So we're going to 3D61F new line and so that's that string part done, and that should be done for this file. We don't have to touch that again. Then we'll do FAHR, and then here's the fun part. Here's another. Remember how I said you can write this a lot better? I was not wrong. 5.0 divided by 9.0 9.0 times and then another statement a HR minus 32. And so what we've essentially done is we've made the Fahrenheit printing program way smaller. In fact, a few, so we have a total of 10. Yeah, so we've cut off like 5 or 6 lines at this point. And so, anything else that we can do? Because I'm... Oh, here we go. We'll do the simple cat program that everyone usually looks at whenever they're writing things. So, close all of this. We'll get rid of all of this, actually. So goodbye to that Fahrenheit loop. Goodbye to Fahrenheit itself. We do not need to define you anymore. So, okay, so we're going to do int c. Hold on a minute, this doesn't look right. Okay, yeah, no, it is. So int c, then we're going to do semicolon, so that's variable prototype at the top, so we know that it's defined throughout code. We're then going to do c equals get character, gets GTCHAR. This is the function defined in standard.io.h, which essentially provides us Okay, so get character, and then we'll do a function end this. It's a variable definition. While C, and we're going to do a funny thing, does not equal EOF for end of file, which would be like Control C or whatever you define EOF as. And then we're going to do a new line, curly brackets, spaces. We're going to put the character right back onto the console. Put character C that prints for an integer. So characters in C are represented by integers. Don't know why they are, but that's fun. Well, no, not really. It's depending on what kind of type that they are. If you're doing get character, then int is the way to go for the basics, unless you really want to get into the actual like characters themselves. C does not equal EOF. Put the character, and then C equals get character again. And so long as if you run this on your computer, so long so long C does not equal EOF, either Control C, which would just quit the program regardless, or if you like provide the end of file character itself, which is some combination on your keyboard, it will stop. Usually the file is denoted by some random number, probably like so insanely high that nobody really cares about it. But if we going through here, oh, here we go. So we'll change this character counting so that we don't have to do this put and get character. We're going to we're going to get rid of most of this, and we're going to keep that C there because we're going to. So what we're going to do, get. Oh, I've just completely forgotten to start. Oh no, that would definitely not be good. Well, get character does not equal EOF. So we can get rid of this. We need to make another definition at the top. So we replace int C with long NC. There's going to be a lot of characters. NC, new line. What we're going to do is we're going to plus NC, or you can do that backwards, NC plus plus. Do a new line. Then what we're going to do is print F %sign 1. Wait, no, an L. Yes, no, it isn't. 1D. From here, what we're going to do is we are \n. Oh my goodness, can you stop printing multiple? From here, we're going to provide NC, close that off, and now we have a simple character counting program where so long as get character does not equal EOF, we're going to increment NC, then we're going to print the variable, we're going to print the number of NC. So usually it's 0 at the start, there'll be 1, then 2, and then it keeps going up and up and up for more, like for some more, how many characters are you putting in the input? Character is usually represented by one number. Or not actually one number, sorry, a character is A, B, C, D, E, so on and so forth, like through the entire, like the 27 letters in the alphabet are considered a character in C. So the statement plus plus NC semicolon presents a new operator double plus, which means increment by 1. You could instead write NC equals NC plus 1, but plus plus NC is more concise and often more efficient. There's a corresponding operator, 2 dashes or 2 negatives to decrement by 1. The operators plus plus and minus minus can either be prefix operators, plus plus NC, or postfix operators, the NC plus plus, like I said before. These two forms have different values and expressions, as will be shown in the in what we are going to see in chapter 2. But NC plus plus and plus plus NC are both increment the same variable, at least for the moment. So we'll stick with the prefix form. So it's negative or negative NC or the one above it. And so essentially, the character counting program that we just wrote, the long NC while get char does not equal EOF, accumulates its count in a long variable instead of an int. Long integers are at least 32 bits, although on some machines, int and long are the same size. On others, int is a 16-bit number with a maximum value of 32,767, starting at 0, and it would take relatively little input to overflow an int counter. The conversion specification, %1D tells printf that the corresponding argument, LD, is the corresponding argument is a long. Check the 2 most recent messages. Program is online C interpreter. One in comparison between pointer and integer. We need to do the funny, haha. I forgot to state get character as a function, so you gotta do the function calls. Ooh. So you do that. It may be possible to cope. Oh, okay. What would you? No, you wouldn't use that. Okay, yeah, because we do a for statement. That makes sense. We'll get another quick one. Sure. Let's do word counting. All right. So we're going to write an even more at the very end. Oh yeah. We are missing a. Do that.
The long has to be defined to 0, or so it just starts as a random value.
The long doesn't have to be defined to 0. Long is already just defined, so it'd be starting at 0 regardless.
But if I run it in like an online compiler, it just starts as a random value, unless it's explicitly defined as 0.
It should just provide you with the variable. It should just set it as 0 or null, which NC will get plus plus, so it'll set it to 1. You could do long NC equals 0 as a simple as a replacement for it, which would be a lot helpful in that case. ASDF negative 91,300. That's not good. Yeah. Define NC equals 0. So no variable specifications, because this is not good. Oof. Okay, so this one's even more painful. Amazing. We get to learn a bunch of cool things today. So we're going to go through about what time is it? Yeah. A couple more coding examples, and then we'll get to that. We'll get to the ending. So. Int C. Whoa, no, I do not want an L. I'm having so many issues with my keyboard today. Amazing. So we'll do int C, NL, NW, NC, and then states. Whoa, this fell over there. then what we're going to do is, fun thing. We've get in C, we have things just like how we've got the include block up at the top. We have things for simple preprocessor direct. So EFIN define and then space in caps in. We'll set this to be 1. So space 1. And then next line, hashtag define out as 0. So now what we're going to do is we're going to go back into the function. We're going to do state. Come on. State equals, and then it's a fun part, because we've defined out at the top, we can essentially place out with 0 and in with 1. So anytime out or in or whatever you put in the defines reference, they'll just kind of show up and get replaced by the preprocessor. So set to out now, what we can do is we can do multiple NL equals NC. Oh no, NW equals NC equals 0. From here, hit a new line again. That's not on the same line. It's going to equal this. So we'll do that. From here, we're going to do a while loop. This means that while here's another fun thing, because so here C equals get character to function open and close. At this point, you might as well just be writing in a Lisp language with all of these braces and brackets. So C equals not equal end of file. So it's not equal. We will then do a new line when I check my syntax. Yep. Oh, no, hold on a minute. I'm doing a stupid, with accident. The keyboard's gonna head and press another button for me. So, while get character does not equal end of file, we're going to increment NC twice, or actually once, sorry. So we're going to do plus plus NC, do a new line. From here, we're going to check to see if statements. Here we go. If C unbalanced brackets in the while loop. Oh yeah, forgetting. Not only great with Steam today. So if and we'll do opening brackets. We'll do if C equals, and here's the little fun part, defining characters as single quotes, \n. So this will make sure that if the character is a new line, so as we're looping through all of the characters in the input text, if C is a new line, we'll increment the new line character twice. Once actually. I should keep saying once, but if C equals new line plus NL, then we're going to close this bracket or brace block off. Then we're going to do another if statement, and this one's going to be a lot longer. So if you have a keyboard near you, I'd highly recommend using it besides the one in VR. If C equals, we'll do a space. And then here's a little fun part. We use the pipe character that you usually find when holding down shift and then doing backslash. This essentially states that if C equals this, or it equals that in the same line, if C equals a space, C equals a new line, double pipe yet again, C double equals percent sign T inside of the things. Let me just fix that up. No, sorry, backslash T, not percent sign T. And it's not. So percent sign T. I'll close that out. New line. State. Come on. Equals out. Ooh. Do that. Else if well actually we'll do an else if state actually that's not variable state double equals comparison. Then what we'll do is we'll set state in state okay. Double equals in. Actually, no, single equals not double. This is not, and then amazing. And then we'll do plus NW, so new word. So essentially, what we've written. Yeah, I do need brackets. Give me a second. So far, what we have written is we're doing a simple check. While we're defining some variables at the top, making sure that state is out, provided by our preprocessor at the top. Defining all of the ones that we need: new lines, new words, new character equals 0. Then we're going to do a check to see while character or C equals get character does not equal EOF. So we essentially ask get character to give C a character, then we check to see if that's EOF. And so long as it is not EOF, we're going to increment the new a new character, so we'll get an increment on that. If the character is \n or a new line, the character line or a T, we set the state to out. Otherwise, if state is out, we set it to in, increment the new word, so that we know that we're inside of a new word. And then what we can do is we'll close that off. Do another one. And then from there, from here, what we're going to do is we're going to do this print. Now, we're going to do a print F statement because we're going to print all the variables that we kind of have through this while loop. So what we're going to do is we're going to do 3 percent sign D characters, percent sign D, percent sign D, percent sign D. Make sure to have a space between them. do \n because, fun fact, printf does not print new lines, which is a sad thing, but I guess that's just how programming works, you know? And everything expectedly works the way that you want it to. So we'll end that off. Now we need to provide the argument nl, nl, then it is nw, and then nc. So as we go through this, it will print all of the characters that we got for that specific run. Yeah, for that specific run before we get to the ending. So then we need to do that. Do a new line. And then that is it. So as we go through this, we have defined at the top our in and out through the preprocessor directives. Our include, why are you not running these on CodeRunner? Because it broke, it exploded. So what we do is we include standard io.h, define in and out to be 1 and 0 respectively, set up a main block, set up some variables, C, NL, NW, NC, and state, define state to be out or 0, define that NL, NW, NC equals 0, and while the character from get character put into C does not equal EOF, we're going to increment the new character, and if the character equals a new line, we're going to increment it to just be new line, and if C equals a space, a new line again, and it equals \t, or a tab in the terminal, state is out, returns it back to being in. We increase the new word counter, and then when you do like Control D or Control C, it prints NL, NW, and NC. What time is it? Okay, let's see what else we have on the roster for now. Oh, yeah, that's right. So as we're going through this, we've got one last one that we have to go through. That brings us away from the scary territory and back to something that tells us that we're stepping in the right path. So if we go through here, we're going to go, we'll do int main. Opening brackets, that's a Z, that is not opening brackets. And we're going to do new line. We're going to do a function definition at the top called int multiply by 2, capitalizing B and T. MULTI. 2, and this is going to take in an integer. So int x just doesn't work. No, it's because CodeRunner is not set up to be running on Windows correctly. The command doesn't properly work. So what we're going to do is we're going to return x multiplied not by 8. That's not the name of the function. That's called a side effect. It does something that shouldn't be done. So we're going to return x multiplied by 2. Then inside of main, we're going to do int number equals, let's say 5, for example. And so if we int double num equals multiply by 2. Num, because yes, I guess. So from here, we're going to take that number, print f doubles is another percent sign d, and then we're going to do num, and then another one, double num. And so from here, we'll then down, return 0. But there, do that. Oh my, no, there we go. So what we've currently done is we've done the casual things like we did before when we tried to square a box, or sorry, a rectangle. Yeah, it was a rectangle. Yeah, it was a rectangle. We are taking in one integer this time, not 2, and then we're going to return x multiplied by 2. So in our main block, we're defining a number to be 5, doing a double number. So int double num equals multiply by 2. This is calling the function, getting the with the arguments num, and returning it will be now 10. So if we come in here and we put a comment on this so that people can actually read it. So we'll do 10. It will then print it. First number or first format specifier doubled is second format specifier, num and double num. So 5 doubled is 10. Then we return 0 after printing it to the standard out. Is that about it? Is that about it that I have? Wow. Okay. I guess I managed to get through all those. Well, it is nearing the end of the class. For now, I'm going to be having Q&A